Hi, everyone. As you can see on the screen, this lecture is intended to give you a basic overview of the modeling process, of modeling principles, rendering principles, and then since a lot of you have been spending most of your time in the last couple of years working in Rhino and not SketchUp, it ends with an overview of SketchUp, the basic tools, and this is kind of a prerequisite for the workshops that we're going to start in 414, starting on Thursday. So I'm going to begin with this kind of intro about modeling purpose, and let's just start taking a look at that. Now, one of the reasons behind the graphic that's up here is that when it comes to 3D modeling, we all come with baggage. We all have preconceptions. Some of you decided early on that you didn't like SketchUp, or you did like it, or you like Rhino better, or maybe you've used Blender or 3D Studio or Maya or some of the other 3D software in there. And if you go online, everybody has their own favorite piece of software. The purpose behind this lecture isn't to convince you that SketchUp's the best or Rhino's the best or anything else. It's going to focus on SketchUp, but the point really is that you need to have a good understanding of what 3D software is and how you can use it. So the use of 3D modeling software for design and visualization really offers us a whole myriad of possibilities and challenges and controversy at the same time. Because like any media, modeling software can influence the way you design, the alternatives you explore, the forms you work with, and really every decision you make throughout the design process. That's why it's really important that you learn to use it mindfully, creatively, and with as much skill as possible. So we'll talk about some of those variations, both in terms of technical skill, but also in terms of how you think about it. So developing your skill is really the easy part. You do need to learn commands, you need to learn process, but through practice and repetition, you can do that pretty easily. Being mindful and creative with it is really a lifelong process, and that's one of the things that I see disappearing in our classrooms today, that 3D software is being taught in a very linear and scripted way, so that you get a set of steps, this is the way you do it, and that's all there is to it. So you don't really have to understand how the software works, how to discover new methods, what really are the best practices for any particular type of 3D modeling software. You can't determine that unless you really understand how it works and kind of how it's structured, how the programmers put it together, and how they approach 3D visualization. So that's a lifelong learning process that you're going to have to really be engaged in. I'm hoping even throughout the rest of the semester that we have that you will try to be more engaged with that, as opposed to even the fact that I know lots of you prefer Rhino because it has a command line. You don't remember the commands, but you know if you type something in, it'll come up and then it'll jog your memory and then you can do it. But if you have so little understanding of how the software works that you have to type in commands, then you don't really understand the best way to use it. And you might get through, but in the long run, over the course of your careers, you're going to have lots of different programs that will come into play, and you may have to learn something else. So how do you learn 3D modeling software in the best way? Hopefully, as we go through some of these principles, I can challenge you to think about that and really engage in more mindful modeling and really use software to its fullest, not just kind of scratch the surface with it. Okay, when it comes to design, from analysis to conceptualization, to design development, construction documents, 3D modeling really can help you generate, develop, and refine your design ideas. And again, another thing that bothers me a bit in the classroom these days, not just here, but everywhere, is that people seem to use 3D modeling at the end of the process. And the only thoughts about using it during the process is to use something like a Grasshopper to create algorithms that generate forms for you, as opposed to actually just using it as a visualization tool to help your own mind and imagination explore ideas, instead of scrawling everything on paper in 2D form to actually design in 3D. How do you do that in the best way? So we can start with the components of spatial design: lines, planes, primitives, enclosures. You learn all this stuff about these basic elements. Well, those basic elements are all in 3D software. And so there's a logical connection between those things to help us think about basic design and basic visualization at the same time. And we can use additive and subtractive form in composition. We talk about that. You can do that in 3D modeling. Use one object to subtract from another or combine them in an additive way. We can start very abstract and move to realistic. And that's the nice thing about modeling software. You can start at whatever level you want, and you're the one that decides what's appropriate. There's nothing inherently good or bad about working at any of those levels. You just have to decide where's the appropriate place to start. Visualization is important at every stage of design. So whether it's preliminary and you're sketching your ideas, or whether it's at the end stages where you're really trying to show what this looks like in a particular context. And that's one of the things why I have a little bit of issue with some of these types of photo montages. Ultimately, as an expression of an idea or a concept, this is great. But if you're trying to show how something actually looks or will connect to an existing site on a particular day in a particular location with specific atmospheric conditions, these kinds of montages don't tell you anything. They're simply not capable of communicating that information. They're disconnected from the context. They could be anywhere at any time, whereas these images down below are much more specific. So again, there's a time and a place to use these types of montages, but they're not really that effective for explaining design ideas, especially to lay people who aren't designers. And you end up talking more about ideas than actually being able to show your ideas and have someone understand what it's going to look like and why you've made the design decisions that you've made. So let's use our visualization images to really explain our designs, not just put them up there as pretty pictures and then proceed to talk about it without really referencing those images at all. Then they really take a lot of time and they don't really serve any valuable purpose. Now, the 3D software has the ability to generate all types of images. So from the 3D model, we can generate plans of sections and elevations, perspectives, bird's eyes, eye levels, whatever you want. So that's another big advantage of working in the 3D software from the very beginning, because those are all the things we want to explore. We want to be able to communicate those to others around us. We want to visualize them ourselves as we go through the design process, and then we want to communicate those to our colleagues, to citizens, to our clients, whoever that might be. And we can use 3D software to do quick diagrams. We have post-processing options, but one of the things I like to push is that the more you can do in the 3D software, the less time you spend fixing things or adding things. If you have all your design elements within the 3D model, then it's easy to show your design ideas at any point through the process and generate finished design visualizations as well. And then finally, just really focus on being able to model wisely and thoughtfully. I put these slides together last year, and you can see already it's Lumion 7. Now we're at Lumion 8, 8.5 actually is the most recent version. So things change from year to year, and if you only understand one method of approaching a 3D modeling program, then when the interface changes or they add new features, you will never take advantage of any of those things. You get stuck in a time where basically repeating the same practice over and over again because you don't really know how to explore the new ideas that are out there. And actually, there's a huge difference between Lumion 8 and Lumion 7. They added a whole bunch of new features, and then even from Lumion 8 to 8.3, they add the live sync functionality with SketchUp and Revit. So even within a few months, there's new features that come online. And so really understanding the software and trying to figure out, well, how do these new features work into my workflow? How can they make me more efficient? How can they help me design better is really important. Okay, let's take a look now at modeling process. This is really talking about modeling mindset, and with SketchUp, edges and faces, a little bit of topology, which we'll talk more about later, how we work in 3D on a 2D monitor, and then a little bit about adding accuracy. So first, the whole modeling mindset is just really being able to look at landscape elements or at the landscape or the real world and analyze and abstract the built and natural world so that we can model it efficiently. So as you can see here with these walls, we've got one wall with some iron railings in here. But if you think about that in a modular way, you can break it down. So you end up modeling one of these, one wall and one column, and then you put those together, make a component, repeat that, assemble them, and you've got the entire wall, but you didn't have to model it from scratch. So being able to think about the hierarchy all the way through the process, using groups and components to organize the geometry, being able to make scenes, saved views that we can use to present the model and move around quickly even during the modeling process. Now in SketchUp, edges and faces are always straight. And again, SketchUp is a surface modeler. It's not a solids modeler. So we have to understand that. If you understand that, then you'll model very efficiently and actually works well. If you don't understand that, then you're going to end up modeling the wrong way, inefficiently, and you will get frustrated with SketchUp because it will appear to do random things, but it's not random at all. You just need to understand how it works and model within that system. If you do that, then it works very fluidly and it's very efficient. And again, just like edges, faces don't have any thickness. It's one of the things in SketchUp, you don't create walls, they just have a surface with a front and a back. And that creates some issues when you're maybe working with something like V-Ray and adding materials, or you're cutting through and you want to see thickness. So again, you just have to be aware and negotiate those things. Now, even though we're working in a 3D model, mathematically inside the memory of the computer, just like drawing, we're still looking at a projected image that's on a flat screen in front of us. So when we're working on this two-dimensional surface, then how does the computer know whether we're moving up or down or left or right and back and forth in space? So there are things that help us do that. We've got inferences in most programs like OSNAPs in AutoCAD. And again, these are your friend in SketchUp. It's how we can tell where we're modeling within the three-dimensional world. Sometimes they can be a little frustrating. We can use the Shift key to lock those inferences in. So sometimes the quickest way to draw in SketchUp is to not draw where we want the actual line to go, but to be snapping to an object or a corner or a line that's off of that point and then clicking by using a constraint. So we'll demonstrate that, and I'll remind you that when we sit down at the workshop. Again, that's a process, understanding how SketchUp uses inferences instead of just, you can't, it is a pencil tool, but you don't always use it like a pencil. You have to think about how SketchUp understands inferences and snapping. You can encourage inferences by the way you position the view, and you can discourage them. You cannot turn them off. So that's one thing. Sometimes it's, if you have a line that's just off parallel to one of the major axes, it gets really tough to be able to have it snap to that line itself instead of the red axis. But there are ways you can manipulate your view and zoom in and out to help the inferences work better. And of course, working in 3D using the mouse in SketchUp, still the most elegant navigation interface I think there is, to be able to zoom in and out, pan, scroll. And so you always, because we're working on a 2D screen, we're always changing our point of view in order to model efficiently. You can't just let it sit there and at one view. You have to move around throughout the space to get the best view possible. And of course, we can add accuracy. SketchUp is designed to kind of work in a free-form way, but anytime we can control the snapping increments in the model info, and we can also use the measurement input box to type in whatever numbers, feet and inches, meters, whatever it is that we want. Okay, now let's take a look at some modeling principles. Now, one of the challenges, obviously, we've talked about this, you probably remember this from 251, is just the complexity of the real world. How much detail is enough? And this has always been the most difficult thing about working with landscape architecture, is because by the time we just simply get the context of a site in, we've already got a ton of geometry. Now, fortunately, with tools in SketchUp like logwork plants, where you can use proxy plants that are simple and then see the detail in the rendering, we can have the best of both worlds. Or something like Lumion, which we're going to be working with, where it's designed to be able to display these highly detailed plants and materials in real time. And that's the way software, 3D software, is going. I just read something somewhere about first ray trace interactive video game, computer game. So the level of realism and the ability to handle that in real time is going to be commonplace within your career. So if you can model in real time and see everything like you're really manipulating things directly, then why wouldn't you want to do that instead of working in abstraction? I mean, that's ultimately your designs are going to get built with real materials and real plants. And the closer you can get to that, we've always worked with representations because it's all we had to work with. But now we're getting to the point where we can have more detailed representations. And I think it's silly to look at it as a hindrance instead of a huge opportunity that we should take advantage of. Of course, one of the challenges is always learning the software. If you don't use it a lot, you forget it. You go away for the summer, you come back, you don't remember the commands. You do have to kind of keep with it. But once you do, you start making connections, and it allows you to learn things really quickly. Also, learning modeling process. It's not just about knowing how the tools work, but what's the best way to approach modeling for design and modeling for visual communication. And then once you have a model, if you can't create good view compositions, if you don't really know how to use it to communicate clearly, then it's not really going to be very effective. Having a great 3D model doesn't mean you create great views. Also, we can start really thinking about material choices and how that not only affects our design, but affects how things render. And then there's lots of options, even within photorealistic rendering to non-photorealistic. That's another thing. Most renderers now are providing a whole range of rendering choices, not just photorealistic or just basic colors. There are lots of options in terms of watercolor or sketchy style or pastels. And then there's different modeling approaches. I mentioned that SketchUp is a surface modeler. It just understands lines and surfaces. That's it. It doesn't understand geometric primitives. So we've got polylines versus nerves. We've got raster versus vector, and PRR is photorealistic rendering versus non-photorealistic rendering. A lot of these are available within the same packages, but you need to understand the difference between those so that you can make the best choices of what's working for what you need to do. Now, even if something like SketchUp doesn't directly understand geometric primitives, there's a shapes plugin, so you can put these primitives in one at a time as objects. It's just SketchUp sees this as just a six-sided object. It doesn't understand that it's a cube. It doesn't know what its volume is and so forth. But it's helpful for us to think about that, just like we think about 2D primitives in graphic design. We want to think about 3D primitives as a way to abstract more complex forms, and then also use that as a way to see modular repetition and hierarchy within any particular shape. The better you can see that, the quicker you're going to be able to model it. 3D topology is really important. It's basically the breakdown of a three-dimensional model. Just like in Word, you have characters and words and phrases and sentences and paragraphs and sections and chapters. There's a hierarchy to working in a Word document, and there's a hierarchy to working in 3D modeling, and that also relates to how we can edit or transform objects at any of those levels. Generating forms in SketchUp is pretty simple. There are not that many choices. We draw shapes, we extrude them either vertically or along a path, and then we can add and subtract them, and we can create new forms by transforming things like scale, rotate, offset, and deform. So if you understand those basic operations, you can figure out how some programs, software uses different terminology for that, but it's really just a handful of operations that if you understand that, then you can understand how the tools work more easily. And we have to know what we can expect and what we can't expect. If you don't know who that is, that's Clint Eastwood as Dirty Harry. One of his famous quotes was, "A man's got to know his limitations." And so every 3D modeling program has limitations. Within Rhino, for example, you can't just snap and draw on a surface. There are tools that will allow you to draw a curve on a surface or a rectangle on a surface, but because the way it represents curves or curved surfaces, it doesn't, like SketchUp can just snap to any surface and you can start drawing right on it. You can't do that the same way in Rhino. So it means you have to think about modeling differently. One of the things SketchUp can't do is it doesn't work with solid objects per se. It doesn't do NURBS-based modeling, non-uniform rational B-splines like Rhino does. It works with surfaces. It kind of fakes curved surfaces, but it doesn't actually model them as curved surfaces. You cannot create photorealistic renderings without a plugin like V-Ray, in which case you can, and we'll be doing that. And you can't animate objects within the model. You can create animation of your model, but you can't animate objects within it. And it doesn't have full BIM functionality, although there are plugins that enable that as well. And that's one of the things we'll talk about. Plugins in SketchUp are really an essential part of using it. Because by itself, it really is not that powerful. Some of the ones we'll be working with are Scatter, Logwork Plants, Artisan, and V-Ray for SketchUp. But there's lots of them out there. Sketchucation, Extension Warehouse, Ruby Library Depot, probably Sketchucation and the SketchUp Extension Warehouse are the two sites you'll find most of them. And most of them are free, but Artisan costs $45. I don't know what the academic price of Scatter is. The retail price is about $100. So these plugins are essential to use. I would never use SketchUp to do landscape modeling without these plugins. Just doesn't work. I'll be the first to admit it. But the nice thing about the plugin approach is that they've kept SketchUp itself pretty simple. And if you're working in a particular type of modeling, then you find the plugins that make that kind of modeling more efficient, and you don't have to worry about it. One of the things about AutoCAD or about Rhino is it's designed to do industrial modeling for ships or boat hulls or telephones or car bodies. If you look at their website, they don't list landscape architecture as one of the disciplines it's made for. They do list architecture because architects have kind of adopted it and pulled it into their workflow. But it has all those tools in there, and you won't use most of them. So in that sense, it's way more complex. Now you can go in and customize the toolbars and say, okay, I don't want this set of tools. But by the way it's designed, you have to kind of keep a big set of tools available because you need one here, one there, one there, and one there. Photoshop's very basic, and you can pick your plugin set and load those in and work very efficiently. The rendering principles then, let's take a look at this. One is, how much realism do you want? So here's the Logwork plants in their proxy form, and this actually isn't a SketchUp rendering, but this is kind of the detail level they render at. So again, it's not having photorealistic renderings is not deceptive, as some people have claimed. It's simply, it is what it is. It depends on how you use it. Every drawing or visual representation has a bias to it, and photo montage is the same thing. Are they realistic? Are they really telling the client what this looks like? I could argue no, they aren't. They're just as deceptive as any other hand drawing or anything else. So it's really about how you use them. I think one of the things I like to talk about is having renderings that are perceptually realistic, not perfectly photorealistic in the sense that everything is absolutely flawless. This road down here, this is from view. The asphalt's got patches in it. It's dirty. It's got oil stains on it. Building shows wear and weathering bricks. It's not, world doesn't look like it does on the opening day at the completion of construction. Things get worn out, they get dirty, weeds grow in, and so it's really about telling a story, and you have to decide what's appropriate for the story you're trying to tell. And one of the nice things about using things like V-Ray or Lumion is that they can actually bring a lot of detail into a model through the use of materials and texture maps. So you don't have to create that detail in your geometry, which is awesome. One person once quoted in an article I read about one image is worth 1,000 polygons. And so really understanding how software like V-Ray works or Lumion can save you an enormous amount of time. Lumion 8.3, I think, or 8 and up, has a rounding feature. So one of the things that really tells you that this is a 3D model image and not a photograph is that most 3D modeling software, all the geometry has hard edges on it. So the edge of a table or a bench or a wall. But in reality, no surfaces have this perfectly sharp 90-degree angle. They all kind of are rounded off. And so if you have to do that within the geometry, there's a plugin in SketchUp called Round Corner. You can do that, but it's an enormous amount of work. Well, now in Lumion, you just pick a material and say around the corners and adjust how much you want. It automatically does that for you. So saves a lot of time, keeps the model simple, does all the work in rendering. Materials, because of that reason, are really important. And understanding how materials work in V-Ray or in Lumion and SketchUp are really important in terms of size and scale, bump maps, texture maps, or displacement maps, or diffuse maps. These are all things that you need to understand to make your modeling much more efficient. Okay, lighting is really another important aspect. Lighting is super important in photography, but it's also essential to rendering. If you don't understand how to light a scene properly, whether it's a day scene or a night scene, the same rendering can be really good or really bad. I mean, the same viewpoint. It just really depends on how you use the lighting and how materials react to lighting. And certainly when you get into night scenes, which is something that we want to be able to do for the Pittsburgh studio. The strip is known for its nightlife. We can't just show all the images about what this place is like during broad daylight. Lots of people are going to be experiencing it at night as well. Composition, as I mentioned before, we need to think about center of interest, focal point or depth of field, framing, again, lighting, and how we place people within a scene, not to crowd it out, but to actually help the composition. And then we come down to ethics. Okay, this is one of these big discussions. So which of these three images here is the most truthful? Well, what does that mean? Is it the most realistic? Is it the most like what you will see when you're there? Or is it about communication? So again, I think you're, as the designer, as the creator of the visual, it's up to you to explain what your image represents, whether it's hyper realistic or not, and that depends on what you're trying to use it for. So all these images have a purpose and they're useful for communicating certain information. But let's think about what it is. We just can't crank out montages for everything as though that's the most effective communication tool. Even a beautiful sketch rendering like this may not be the best. Perhaps there's times where this more perceptual realistic rendering is too detailed and it's not the design hasn't really been formed. So this is kind of promoting an image, a design that you haven't really figured out, and that's dishonest. But that's not about the software, it's about how you use it. And then finally, a quick SketchUp overview. These are things we'll just review on Thursday, but take some time to go through and before then and just refamiliarize yourself with this if you haven't been using SketchUp. We'll talk about arranging the tool palettes. Unfortunately, in the Stuckman building, without roaming profiles, it's really a pain to do. So I think we'll set it up and limit the amount of plugins that we have showing. But when you come to another machine, you're gonna have to rearrange them all over again. And I'm sorry it works that way, but unfortunately, that's not SketchUp's fault. That's our IT staff's fault. And it does make it a little more inconvenient to use, but it doesn't take that much time to set them up. Talk about things like OpenGL settings, preferences, snapping lengths, all those kinds of things. Most of these will be pretty straightforward. We'll talk about the 5-part interface. SketchUp is really simple and elegant. It's not that hard to figure out and learn once you get things laid out there. So we've got the modeling window, the menu bar, the toolbars, dialog boxes, status bar, and there's lots of commands that you get through context menus as well. So usually more than one place to find a command in SketchUp. Modeling tools are a real basic set. So here we go. We've got line, freehand, rectangle, circle, polygon, and arc. And there's some variations within that, but basically, that's the set that we have to work with. Pretty simple. The principal tools, the select tool, the paint bucket, the eraser, and the make component tool. Usually use the eraser and the select tool. Again, keyboard equivalents to get used to using the space bar to go back to the select tool. B for the paint bucket, E for eraser. The line tool, most primitive, but totally flexible. You can use open or closed lines. You can practice inferences drawing that to keep the lines parallel to one another or perpendicular. And we can use the measurements box to actually input specific dimensions if we want to. Freehand draws a continuous line, but it's what's described as a curve in SketchUp, not a polygon. So you can't edit it without exploding. And when you explode it, it's just a bunch of line segments. So this has some value, but I tend not to use it very much unless I'm using a Cintiq pen and drawing contours or something. But you don't have quite as much control. Like to draw a sidewalk or something, I would use arcs and tangents as opposed to the freehand tool. The rectangle has a couple variations now, corner to corner or rotated rectangle based on 3 points. It will prompt you for proportions such as a square or the golden rectangle. And again, you can put in measurements in the measurements box to create a rectangle of a certain size. Now, when you create a closed shape like a rectangle, it automatically creates a face. The line tool will only create a face when you create a closed shape. Circle creates closed circles, uses the center to edge method. Once again, measurement box, not just for input for the radius, but for the number of sides, which you need to put in before you start drawing. But you can always change that later in the model or the info box once the object or circle is created. And because it's a circle, it extrudes with smooth faces. It looks smooth, even though you will see facets around the perimeter of the circle itself. Polygon tool creates closed regular polygons like a hexagon or octagon, for example. Similar to the circle, the difference is the tool actually looks the same. You can put as many sides as you want. The difference is when you extrude it, it will extrude as faceted faces. Each face will be a flat surface. You won't see it smoothed off. Other than that, the circle tool and this tool are pretty much the same. Arcs, there's a number of options using the arc tool now, some that create a pie and actually close it in. Other ones like 3-point just give you a beginning and end and a bulge distance, or you can put a radius in itself. So again, it gives you a really quick way to do kind of free form, curvilinear, arc and tangent type forms. And these are just some examples, which I'm not going to spend a lot of time running through, but you know, something like this that you can do a quick model in SketchUp and use as a diagram. This illustrated kind of the engineered breakpoint so that the cell tower doesn't land on somebody's house over here in a big storm. This is actually a rendering from view, but it kind of shows the kinds of things. In this case, this was an example where I scattered some leaves around, again, to show it perceptually realistic. It's not, there's like this time of year, the leaves are still in the trees, but they're starting to come down. That's a normal part of our perception of spaces. And you can do that in SketchUp with the scatter plugin. Just make a few leaves and it can scatter them around randomly. This rendering over here is from SketchUp using V-Ray. And again, fills in, got grass here, got materials with bump maps on them. So again, you can keep things pretty simple in SketchUp and and always go back to add the detail in the materials themselves. I think these are the lobwork plants. You can see here we get the water and cut a section through, but just be able to use this to really quickly create whole bunches of diagrams. And this is another example of, here's the model in SketchUp. You can't see a lot of it, but this is very simple. And by using scatter and lobwork plants, you can create a much more highly detailed and realistic rendering, even though your model itself is really quite simple. Okay, so I think I'll end there. Hopefully this will give you a little bit of a head start to get you thinking about the modeling process, particularly in SketchUp. And when we get together Thursday, I'll have a little exercise for you to go through and just kind of as a refresher for those of you who haven't been modeling as much. And then we'll move on to talk about how it connects to Lumion with LiveSync, and then spend the rest of the workshop times over the next couple weeks introducing you to Lumion and showing you some of the new features.